Hello and welcome to AI for Developers. I'm Chaitanya Talking Bot. Today's lesson is titled Neuro-Symbolic AI, combining deep learning with logic for smarter systems. Imagine you want to build a super smart helper for a computer. AI, or artificial intelligence, is all about making computers do things that usually require human smarts, like understanding language, recognizing faces, or making decisions. But sometimes, current ICE can be smart without really having common sense. We want to build AI systems that aren't just good at one specific task, but can understand the world more broadly, much like a person does. Think of deep learning like teaching a child by showing them thousands of pictures. You point and say, "This is a cat. This is another cat. This is a dog," over and over. Eventually, the child, or AI, learns to recognize a cat just by seeing patterns in the image, without you giving specific rules. It's fantastic at finding hidden patterns in huge amounts of data, like images, sounds, or text, and making predictions. It feels its way to an answer, but often can't explain why it made that decision. As a developer, you feed it lots of data, and it learns to spot things. Now, imagine teaching that same child using clear, logical rules. If an animal barks, it's a dog. If an animal meows, it's a cat. This is symbolic AI. It works with symbols, like cat, dog, barks, and applies logical rules to reason and make decisions. It's great for tasks where you need clear, step-by-step thinking, like solving a math problem or navigating a database. With symbolic AI, you can usually see exactly why it made a decision because it followed a set of defined rules. As a developer, you write these rules, and the system executes them. Both deep learning and symbolic AI are powerful, but they have their limits when used alone. Deep learning is intuitive but lacks common sense. It might recognize a cat but doesn't know cats don't fly unless it's explicitly shown that. It can also be a black box, making it hard to understand its reasoning. Symbolic AI is logical but rigid. It's incredibly difficult to write rules for every single possible scenario in the real world. E.g., what if a cat hisses instead of meowing? It also struggles to learn new, unforeseen patterns from raw data. This is where neuro-symbolic AI comes in. Imagine combining that child who learned from pictures, deep learning's intuition, and the child who learned from rules, symbolic AI's logic. Neuro-symbolic AI aims to take the best qualities of both: the powerful pattern recognition and learning ability of deep learning, and the logical reasoning, explainability, and common sense of symbolic AI. It's like building an AI with both gut feeling and a clear, logical thought process. Let's say you're building an AI to help doctors analyze patient reports. 1. Deep learning part. An AI model, the intuitive brain, could read thousands of patient notes and learn to identify key symptoms or diagnoses, even if they're phrased differently. E.g., cough vs. persistent hacking. It extracts raw, unstructured information. 2. Symbolic AI part. Then, a symbolic system, the logical brain, could apply medical rules like, if patient has fever, and cough, and fatigue, then consider flu. It takes the insights from deep learning and applies logical reasoning to them. 3. Together, the deep learning part extracts the facts and the symbolic part makes sense of those facts, using established knowledge, providing a much more robust, explainable, and trustworthy analysis than either could do alone. As a developer, you can leverage both powerful pattern recognition and transparent logical rules. As a developer, Neuro-Symbolic AI offers huge advantages for building the next generation of intelligent systems. 1. More robust and reliable ICE. Your systems can handle real-world complexities better by combining perception with reasoning. 2. Explainable AI. XAI. You can often understand why the AI made a decision, not just what it decided. This is critical for debugging, gaining trust, and meeting regulatory requirements. 3. Better data efficiency. Symbolic rules can sometimes reduce the need for the enormous datasets that deep learning often demands. 4. Common sense and reasoning. It helps ICE grasp fundamental real-world logic, moving beyond just pattern matching to true understanding. This allows you to build AIs that are both powerful and transparent. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.